Hi, I'm Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, I wish to tell about the topic quantum mechanics. In that, we are going to see about the numericals related to the quantum mechanics topic. So, first of all, we shall see the formulas which are related to the quantum mechanics. That is matter waves wave equation, which is derived by the de Broglie. So, wavelength of the particle. So lambda is equals to h by p. Lambda is equal to h by p. Where here lambda is the wavelength. Lambda is the wavelength and h be the Planck's constant. So Planck's constant value is 6.625 into 10 power minus 34 joule second. So this is the value of Planck's constant. Lambda is equals to h by mv, where here in lambda is equals to h by p, p is the momentum of the particle. P is the momentum of the particle. So momentum of the particle in the sense mass into velocity. So lambda is equals to h by mv also we can write. And lambda is equals to h by root 2me. Lambda wavelength of the particle or matter wave, lambda is equals to h by root of 2me. So m is the mass of the particle. Either it may be electron, either it may be proton. So if the particle is electron, then mass of the electron is equal to 9.1 into 10 power minus 31 kilograms. When coming to the proton mass mp is equal to 1.67 into 10 power minus 27 kilograms. And v is the velocity of the particle, a is the energy of the particle, and v is the potential which are applied to the electron or applied on the particle. E be the charge of the particle. So charge of the electron. So charge of the particle means, so charge of the electron. So it is 1.602 into 10 power minus 19 coulomb. This is the charge of an electron. K is the kinetic energy of the particle. These are the parameters which are related to the quantum mechanics. So lambda is equals to h by root of 2me. So in this, h is the Planck's constant and m is the mass of the particle, is the energy of the particle. And coming to the fourth one, lambda is equals to h by root of 2mev. So where here in the previous formula, E is the energy of the particle. Here when coming to lambda is equals to h by root 2mev, so this V is the potential energy. Potential energy. So V is the potential energy, E is the charge of the electron, M is the mass of the particle, H is the Planck's constant. So when they give the potential energy, then we'll use this lambda is equals to h by root 2mev to know the wavelength of the matter wave. So Ke is equals to kinetic energy, Ke is equals to half mv square. Half mv square. So by using these relations, we are going to find the momentum of the particle, mass of the particle, velocity of the particle, and we can find the wavelength of the matter wave. So like that, we are going to use this relationship in the further problems. So first, the problem is calculate the kinetic energy and velocity of the electron having wavelength of 0.31 nanometers. So we are going to calculate the kinetic energy and also the velocity of the electron. Electron kinetic energy and velocity we have to find. And what are the parameters they have given? So having wavelength. So the particle have the wavelength lambda is equals to 0.31 nanometers. So first of all we shall see the given data. So wavelength of the particle matter wave lambda is equal to 0.31 nanometers. 0.31 nanometers. So let it convert into meters. So it is equals to 0.31 into 10 power minus 9 meters. So 1 nano is equals to 10 power minus 9. 1 nanometer is equals to 10 power minus 9 meters. So that 0.31 nanometers is equal to 0.31 into 10 power minus 9 meters. And we have to find, this is the only the wavelength have been given in the problem. So we have to find wavelength of that matter wave. So here we don't know the kinetic energy, so we have to find the kinetic energy, and then we have to find the velocity of the electron. Velocity of the electron and kinetic energy of the electron have to calculate. So what is the relation between this kinetic energy wavelength and wavelength to velocity? So which relation will we give? So lambda is equals to h by root 2me. Lambda is equal to h by 2me. So we have to find the energy value. So that we are going to take energy E from this expression lambda is equal to h by root of 2me. So let here we have root. So let squaring both sides will get lambda square is equals to h square by 2me. Lambda square is equals to h square by 2me. So from this we need E value, so that taking E to the other side and lambda square to another side will get lambda square is equals to h square by 2me. In this, lambda square into 2me is equals to h square. So this implies E is equals to h square by taking lambda square and 2me to the other side. So directly we can write only the E value taking into another side. E is equals to h square and lambda square taking into right side. So E is equals to h square by 2m. Lambda square will come. So let's substitute the values of these h, m and then lambda. So E is equal to, h is Planck's constant. The value of Planck's constant h is equals to 6.625 into 10 power minus 34 joule second. And mass of the electron, here they specified electron, so that mass of the electron me is equal to 9.1 into 10 power minus 31 kilogram, and already given wavelength of the electron So here the lambda is 0.31 into 10 power minus 9 whole square. So this value become 6.625 into 10 power minus 34 into 6.625 into 10 power minus 34 divided by 2 into 9.1 into 10 power minus 31 into 0.31 into 10 power minus 9 into 0.31 into 10 power minus 9. So this value will become 43.890 into 10 power minus 68 divided by 18.2 into 0.091 into 10 power minus 18 into 10 power minus 31. So when simplifying this expression, so we'll get the value 2.509. 2.509 into 10 power minus 20 joules. So this is the value of energy. So energy E is equals to 2.509 into 10 power minus 20 joule. So E is equals to half mv square. So E is equals to half mv square, the kinetic energy. So this implies we are going to find the velocity. So previously we used the relation to get the energy. Then this formula we are using to find the velocity relation. So E is equals to half mv square. V square is equals to 2E by m. So let taking a V value, V is equals to root 2E by m or 2E by m whole power half. So velocity is equals to E, we know that E is equals to, already we calculated, 2.509 into 10 power minus 20 joule, and the mass of the electron is 9.1 into 10 power minus 31 kilogram. So substituting, V is equals to 2 into 2.509 into 10 power minus 20 divided by 9.1 into 10 power minus 31 whole power 1 by 2. So let's simplifying this equation. So this expression, we have the value 0.5514 into 10 power 11 whole power 1 by 2. So finally we'll get the velocity V is equals to 234825.1629 meters per seconds. So this is the calculated value of the electron, energy and the velocity. So here we don't know the velocity. We don't know the velocity and wanted to find the kinetic energy. So that in this case we are using this formula, lambda is equals to h by root 2mv. If we know the velocity and we have to find the kinetic energy and also been given lambda value, then we can use directly half mv square to find the kinetic energy. So if we take E is equals to half mv square, so we can use the value mass of the electron, and if they have been given velocity value, then directly we can substitute m and v and we can find the kinetic energy directly by using this formula, which is E is equals to half mv square. But we have to find velocity also here, so that I have taken the formula lambda is equals to h by root 2me. So that from that I'm taking E value. So we got the calculated value 2.509 into 10 power minus 20 joule. So then we substituted in the other formula to know or to find the velocity value, which is E is equals to half mv square. So from that, taking p value and substituting the values of energy, kinetic energy, and then mass of the electron, then we calculated the velocity value of the electron. The other one, determine the de Broglie wavelength associated with a proton moving with a velocity of 1 by 10 of velocity of light. So we are going to determine the de Broglie wavelength which is associated proton moving with velocity. So what velocity? It is moving 1 by 10 of velocity of light, and also been given mass of the proton. So mass of the proton is 1.674 into 10 power minus 27 kilogram. So what are the values here given? Velocity of the proton. So velocity of the proton being given, and then mass of the proton. So these two values have been given. We have to find the de Broglie wavelength of that proton. Okay. So lambda we need to find. We have to calculate the lambda value. So what the data given in this problem is velocity of the proton Vp is equals to 1 by 10 of velocity of light. So it is 1 by 10 part of velocity of light. So that 1 by 10 velocity of light is 3 into 10 power 8 meters per second. So that 3 into 10 power 8 into 10 power minus 1. So 3 into 10 power 7 meters per second. Okay, so that velocity of the proton is 3 into 10 power 7 meters per second. And in the problem itself, mass of the proton is given, that is equals to 1.674 into 10 power minus 27 kilogram. So the formula we are going to use here, de Broglie wavelength associated with a particle, lambda is equals to h by mv. Because we have to find the lambda, so mass have been given and velocity also given, so that we know the h value. So h value is 6.625 into 10 power minus 34 joule second. So that directly by using this formula we can find the, or we can calculate the wavelength of the proton. Okay, so de Broglie wavelength associated with a proton, lambda p is equal to h by mp vp, h by mp vp. So it is equals to h is 6.625 into 10 power minus 34 divided by mass of the proton is 1.674 into 10 power minus 27 into velocity is 3 into 10 power 7. So calculating, we will get the value wavelength is equal to 1.319 into 10 power minus 14 meters. This is the wavelength of the proton. Wavelength associated with a proton. Next, another problem. Calculate the wavelength of matter wave associated with a neutron whose kinetic energy is 1.5 times the rest mass of electron. calculate the wavelength of matter wave associated with a neutron whose kinetic energy is 1.5 times the rest mass of electron. So, given that mass of the neutron is 1.676 into 10 power minus 27 kilogram. So, the given data is kinetic energy of the neutron. Kinetic energy of the neutron. So, what is the kinetic energy of the neutron? That is 1.5 times the rest mass of electron. So 1.5 into ME, rest mass of the electron. So 1.5 into mass of electron is 19.1 into 10 power minus 31 joules. This is the kinetic energy. And then mass of the neutron. So mass of the neutron is 1.676 into 10 power minus 27 kilogram. So have to find wavelength of the matter wave associated with a neutron. So this we need to find the lambda. So the relation mass have been given and then kinetic energy. So that lambda is equals to h by mv and kinetic energy is equals to half mv square. So from this we are going to find the velocity. So v square is equals to 2 ke by m. From this v is equals to root of 2 ke by m. So ke we know that 1.5 into 9.1 into 10 power minus 31. So that a root of 2 into 1.5 into 9.1 into 10 power minus 31 divided by 1.676 in 10 power minus 27. So the calculated velocity is 4.046 into 10 power minus 2 meters per second. So now substitute this velocity in the formula lambda is equals to h by mv. So we'll get the value 9.76 into 10 power minus 6 meters. Where here we know that Planck's constant, mass of the neutron and velocity of the neutron which we calculated previous. Next, the fourth problem. Calculate the kinetic energy and velocity of the electron having wavelength of 1.36 into 10 power minus 10 meters. So calculate the kinetic energy and velocity. So kinetic energy and velocity of the electron. And wavelength also given 1.36 into 10 power minus 10 meters. So the data given wavelength of the electron 1.36 into 10 power minus 10 meters. Mass of the electron m is equals to 9.1 into 10 power minus 31 kilogram. A Planck's constant we know that h is equals to 6.625 into 10 power minus 34 joule second. Have to find kinetic energy and velocity of the electron. So formulas we are going to use lambda is equals to h by mv and then velocity v is equals to h by m lambda here from this relation. Then kinetic energy k is equals to half mv square which is used to find the kinetic energy. So from this relation lambda is equals to h by mv. We have to find v. So h, so this will goes this side and this will goes this side. So h by m lambda. So we know h, Planck's constant, we knew m and then we knew lambda. So substituting 6.625 into 10 power minus 34. This is Planck's constant value and then mass of the electron. So mass of the electron is 9.1 into 10 power minus 31 into velocity So, sorry, we're not a velocity, here a wavelength. So, wavelength is 1.36 into 10 power minus 10 whole square. So, here we couldn't get that only lambda is equals to h by mv. So, no square here. No square here. So, just v is equals to h by m lambda. So, that 6.625 into 10 power minus 34 divided by 9.1 into 10 power minus 31 into 1.36 into 10 power minus 10. So, the value of velocity is 53.5 into 10 power 5 meters per second. So, substitute velocity in the expression K is equals to half mv square. So, the kinetic energy of the electron is equals to 1 by 2 into kinetic energy. So, we are going to finding the kinetic energy. So, it is equals to 1 by 2 into 10 power, 1 by 2 into 9.1 into 10 power minus 31 into the velocity value 53.5 into 10 power 5 whole square. So, the calculated value is kinetic energy value is 1.304 into 10 power 17 joules. So, this is the kinetic energy and velocity of the electron of which have a wavelength of 1.36 into 10 power minus 10 meters. And another problem, calculate the wavelength of an electron raised to a potential 15 kilovolts. Calculate the wavelength of an electron raised to a potential 15 kilovolts. So, solution. So, first of all, we shall write the given data. So, the given data is potential energy P is equals to 15 kilovolts. So, 15 into 1000. So, 15,000 volts. And we need to calculate the wavelength of the electron lambda. So, lambda and potential relation is lambda is equals to 12.26 divided by root v. This is for the electron which is accelerated through a, or the electron which is experienced potential energy. So, the wavelength of the electron which experiences potential energy, the formula. So, lambda is equals to 12.26 by root v. So, substituting v value. So, it is equals to 12.26 divided by root of 15,000. So, that the lambda value, the wavelength of the electron which experiences some potential 15 kilovolts is equals to 0.1 angstroms. 0.1 angstroms. So, we can calculate similar problems with similar potential values also. We can take 6 kilovolts, or we can take some other 36 kilovolts of potential. So, like that we can take and can calculate the value of lambda. So, in this case, so when the particle experiences some potential value, so in that case, so we'll use the formula lambda is equals to 12.26 divided by root v. So, this expression came from lambda is equals to h by root 2m ev from this. So, substituting the standard values, that is, we know the mass of the electron, we know the mass of the charge of the electron, and we know the Planck's constant. So that we, when substituting the standard values or known values, lambda, the wavelength expression have been reduced to lambda is equals to 12.26 divided by root V. So like that, this wavelength have been reduced. So that reduced wavelength is used here. That formula is using here directly. So lambda is equals to 12.26 divided by root V. So that in the place of V directly we can substitute the potential value and can find the lambda value. So here lambda is equals to 0.1 angstroms. So this is the problems which are related to the wavelength of a matter wave. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.